Hi, so this is a video editorial for the LeetCode Biweekly contest 185. This contest was like extremely trivial. I'd say all the problems are extremely straightforward, and if you even know the concepts in their most basic sense, you would be able to solve all of them. It took me some time because I messed up on my understanding of Q2 and I wasted a lot of time. And it for some reason problem 2 was the first problem which loaded, so I wasted a lot of time on that. But then I skipped and then solved all of the others, and then returned to that and solved that as well. So as always, I'll be going through my solutions in the order in which they appeared in the contest, and after that I'll attach the live solve section where you can see how I approach the problems in the contest itself. So problem 1, okay, to be fair, I actually like problem 1. It was a constructive problem, which means how I approach constructive problems was instead of finding a solution, a generic solution, I tried to find the most convenient solution for me. So here what we had to do was we are given a n into m grid. I swapped n and m and made n rows and m columns because I'm used to that more. And we have to ensure that we have to add walls, which is this obstacles and free cells in such a way that there is only one path from the top left to bottom right. So this has, the examples have some paths, but what you can observe is like, 1 second. The easiest thing for me to implement would be assume we have this grid. My bad. This is a valid path, right? So if all of these cells are blocked, then you can only take this path, which is why to implement this, you can enable this construction where you create a matrix of n cross m and then just initialize it with all of the obstacles and then clear the path. So this would work in the n cross m complexity which passes since n and m are less than or equal to 25. Problem 2 was like, for some reason I couldn't understand this properly even though the problem was straightforward. Basically, we are given an array lights where the ith light bulb is at I, and if the value is 0, that means it's off, else the value is of V, which is the value, right? And it can illuminate the from I minus V to I plus V, all of the cells present there. And so obviously a cell is visible if it's illuminated by any light bulb. And we have to find the minimum number of extra light bulbs to add such that all of the cells are illuminated. This is the part I misunderstood. I thought this will eliminate I minus j to I plus j, but basically what you have to do is, given a strip, 1 second, given this strip, first assume the light bulbs have illuminated subregions, which can be calculated in a single or double pass in linear time. After which the array will have some sections which are not illuminated, right? We can iterate over these sections, and if the size of the section is some x, then the number of light bulbs required would be CL of x by 3, right? Because like for one section you need always 1, but for if the size of the section, the unilluminated section is 2, then you can also illuminate them in 1, since this will illuminate this and this. If it is 3, then also you can place it in the middle and illuminate all 3. But if it is 4, you have to use 2, right? Since a single light bulb won't do. So basically my solution was, in single pass, I first of all checked which all cells will be iterated by this, find the how much right the region is being illuminated and how much left the region is being illuminated, and then in this I figure out the size of the current segment which is illuminated and then seal by 3. Alright, so this was Q2, fairly straightforward. I'd say Q3 was even easier. Like the problem, I thought it was something more, but by the name I thought it was going to be more involved, but it was fairly straightforward. Easier than the usual Q3. I'd like to add that as well. Basically, we're given a tree. It's a directed tree. I mean, trees are directed only, but still, we have a parent task and a child task, and we are given the base times. And we have to find the finish time of the root. And to find the finish time of some node, we have to just perform this. If it's a leaf, then the finish time is that time only. But if it is a non-leaf, then we have to find the minimum and maximum finish times amongst its children, and then find its own duration, and then do this. Finish time of that current task is latest plus own duration. And we have to do this find it for the root. So basically, and for the previous, for the previous problem as well, n was less than or equal to 1e5. Ignoring that, in this problem, since we are just given the instructions, we can just perform this in a DFS, right? Even if you don't know anything about trees and you just know how to do a DFS, then this problem is solvable. DFS because we want to process the children first. So this was my implementation. Basically, if it is not a leaf, that means I created the tree. I created a directed tree only. I only added the edge from this, the parent to child. Which is why if there are children, then we find the max and minimum finish time, and then we find the on duration, and then we return the max time plus on duration, which was what was asked here. Or if it is a leaf, then we just return that, and at the end return the result. So this was Q3, straightforward. And Q4, I read the name and like this is literally digit DP. I thought it would be harder, but then if you read the problem description, it is extremely trivial. Basically, if you know, like even if you started digit DP, you will be able to solve this problem. What we have to do is count the number of integers in the range L to R, which is a digit DP setup, such that the absolute difference between adjacent such that the absolute difference between adjacent digits is at most k, and obviously return this in a range L to R and absolute differences as defined. So and less than equal to 10 power 15, and k obviously since it's a digit, the difference, absolute difference, can't be outside this range. So obviously, since this is digit DP, we would need a tied. I've started using started state in digit DP since like it doesn't add much in the complexity, and during the at least during the contest, it makes the implementation easier. So yeah, in my digit DP thing, obviously I'll solve for R, I'll solve for L minus 1, I'll subtract that. This was my, when I'm solving for some R, let's say for some X, memset. Here I'm not iterating for specific sections since the size of the array is 200, and memset will do this like it will iterate over the memory segment, so it will do it faster. If it were larger, then I would have allocated, like I would have run a dedicated loop for this, but regardless, the states are tied, started, the previous digit, and this, what do we say, index. So obviously, if the number hasn't started yet, that means we can add a digit, right? So basically what I'm doing is as at some state I'm trying to add all of the digits, right, as you do in digit DP. So when I'm adding some digit, if the number hasn't started yet, so that means there were no digit behind me like this. I'm the first digit, so obviously I can keep that. Or if the number is started, but the absolute difference between the previous digit and the current digit abides by the rules in the problems, right? Which means it is less than equal to k. KK here. I just made this KK variable a global, so implementation is easier. Then I just do the digit DP count, and at the end memorize and return. And at the end f of r minus f of l minus 1, and just return this. Like, I would say the contest was way too easy. Like, at least this sort of digit DB problems shouldn't be appearing as Q4s in my opinion. Like, you see the solve count. Yeah, it's 1.3k in just 40 minutes, which is not good for a Q4, but regardless. Alright, I'll just let me know if you have any doubts in the comments, and I'll try to see if I can. I don't think you'll be having any doubts because the problems were so straightforward, but still, let me know if you have any doubts, and obviously I'll attach the live solve section so you can see how I approach the problems in the actual contest and the unnecessary time I wasted on Q2. Alright, bye. Finish time of task, see. Total sort question relevance. Okay.
मुझे फोमो का फुल फॉर्म तो नहीं पता, पर फील रोज करता हूँ। हर हफ्ते नए मूवीज, शोज, ट्रेंड्स, गॉड। पर एक चीज है जिसमें आई एम द बॉस, म्यूजिक। थैंक्स टू स्पॉटिफाई डिस्कवर वीकली, इट कीप्स मी अप टू डेट विद द लेटेस्ट म्यूजिक इन माय वाइब एवरी वीक। सो नाउ आई एम दैट फ्रेंड जो सबको पूछता है, डिड यू हियर दैट सॉन्ग?
Find fresh music that fits your vibe with Spotify's Discover Weekly playlist. Explore now.
स्पॉटलाइन से मैं विजय, अपने प्रॉब्लम्स मुझसे शेयर कीजिए।
हेलो, मुझे ना सब कुछ बेस्ट क्वालिटी चाहिए। फोन्स, ईयरफोन्स, यू नो व्हाट आई मीन। बट म्यूजिक में बेस्ट क्वालिटी कहाँ मिलेगा?
देखिए, इसका सोल्यूशन सिंपल है, मेरे साथ दोहराइए। हाई क्वालिटी म्यूजिक ओनली ऑन स्पॉटिफाई प्रीमियम।
स्पॉटिफाई प्रीमियम।
जी, ग्रेट क्वालिटी, ग्रेट मजे। यू नो व्हाट आई मीन।
Enjoy 2x higher quality audio than Spotify free with Spotify Premium.
अबे यार क्या है ये? अरे my bad, my bad. ठीक है ठीक है ठीक है रिवाइव एंड भी डायरेक्टेड है. रूट 0 है ना? अरे भाई मेरे, सत्रह, 12, 18। Right, not started yet. Previous doesn't matter. फाइट है तो सारे माइनस इधर करना 9 इक्वल टू 0 प्लस and started. तो स्टार्ट नहीं हुआ नंबर, नंबर स्टार्ट नहीं हुआ है, लेकिन अगर नंबर स्टार्ट हुआ है तो एब्सोल्यूट डिफरेंस लेस देन इक्वल टू के कैन मेक सेंस। कैन स्टार्टेड एंड अब क्वेश्चन प्रॉब्लम 2 क्या है, क्या कह रही है प्रॉब्लम? लाइट से एलिमिनेट कर लो पहले गाइस। तो कॉन्टिग्युअस सीक्वेंसेस आ जाएंगे ना।